Good morning to all. Myself G.SELVAKUMAR, Head cum Assistant Professor, Department of ADS and IT. Today we are going to dive into the topic of Introduction to Data Science. First we are see the outline of the data science, data, big data and challenges, data science, data scientist and major concepts in data science. These all the topics we are going to discuss about today. First, the data all around. Lots of data is being collected and warehoused. This type of data, web data, financial data, online trading data and social network data. These data are available in the internet. First, the web data and e-commerce data. Every day, the data are created, generated and processed, exchanged through the internet or e-commerce websites. And the financial transaction also happen in the every day. And online trading and purchases. For example, e-commerce website, we are purchasing or sales or return the product. All the data are stored in the websites. Next one is social network. The social network is all about the social media. Day by day, we are using Instagram, Twitter, and Facebook usage as a very lot. So while you are using the social media, the data are exchanges and generated or processed throughout the internet. Next, how much data do we have? Every day Google processes 20 petabyte of data. Every day 20 petabyte data we can exchange through the internet. And also Facebook also have 6 terabyte of daily logs. The users can share the post and retweet and Instagram reels. They are sharing about 60 terabyte of data every day. And the eBay has 6 petabyte of user data. Every day the eBay like e-commerce website Flipkart, Meesho, Shopsy, etc. They are selling and producing and purchasing over the internet through the data. And 1000 genomes project are 20 terabyte of projects are available in the internet. And the cost of 1 PB of disk is $35. Next we are see about the big data. Big data is large and complex data. That means unsolved problems and complex data or collections is big data. So we can't manage or analyze or processing the traditional data processing tools. So when you are moving the big data, we have to create the new image processing tools and also the data processing tools. For example, Amazon C3 and big data query. These tools are handled for big data. And the three things are velocity, variety, and volume. The volume is nothing but is a size of data. How much size of data we are exchanging from one machine to another machine or one node to another node. The second one is data velocity. The data velocity is nothing but is the speed of the data. How the data get processed from one node to another node or one device to another device. That is calculation of the latency. That means the process of the data, how many times it will take for reach one device to another device. The third one is data variety. The data variety is nothing but the different type of data. That means the big data is not only handling one type of data. It will handle structured data, semi-structured data, and XML data, audio, video, image. So collection of data, the big data warehouse, it will be handled. Next, the type of data we have. The first one is relational data. Table, transaction, legacy and data. Relational data means when you are creating a database. For example, in a student detail, we are creating tables and database and also the information about the students. For example, marks, arrear list, the personal information, etc. Next one is text data. That means web data. Day by day, every day, whatever we are doing in the internet, we are searching in the Google server and getting a response from the Google server. So all the data are called web data. Next one is semi-structured data, XML, the extensile markable language. The semi-structured data is unprocessed data. So processed data, unprocessed data. When you are handling with the processed data, we implement some tools or techniques for creating the semi-structured data to the structured data. Next one is graph data. The graph data is nothing but the data, it will be represented as a graphs. So the image representation of the data. So all the data are collected and it will be converted as a graphs like pie chart or bar chart like that. and social network, semantic web. The social network is nothing but already we discussed about social network, all about that social media data. Whatever your login information or request, followers, that informations are handled in the semantic web. And the streaming data is nothing but continuously delivered data from the one server to another server. Like example is the live streaming data. Next, what do we with this data? Aggregation and statistics, data warehousing and OLAP. Aggregation and statistics is nothing but the data, it will be implemented in the statistical and mathematical problems. For example, if you are going to calculate some person's age or income or some information about that particular student, we have to collect the data from the particular person. After that, we are applying some mathematical problems or statistical formulas to find the solution. The next one is indexing, searching and querying. That means keyword based searching. For example, we have a lot of database. Say for example, we have employee database. If you want to search some person who's coming from a particular city, for example, Salem or Madurai, so we can search the whole database, which person are coming from Madurai or Salem. That Salem and Madurai, it's a keyword. So depending upon the keyword, we can easily search the database. The entire database, it will be search and fetch the data what the user want. Next, pattern match. So the pattern match is for the image. That pattern match is largely used in the medical field. Health diagnosis. For example, the patient having a cardiac problem or some ontological problem. So first the patient, it will be examined by the doctor, and after that the previous history of the other patient's image. So the both images are compared, the image representation. So when the patterns are matched, so the doctors, it will be easily recognized what they are affected area and diagnose the system for the medicine. Next one is knowledge discover, data mining and statistical model. The data mining is nothing but extracting data from the huge amount of data. So huge amount of data, if you are finding number of data or some data from the large amount of data, we can use the data mining techniques. And the statistical modeling, also it will be apply the statistical formulas and mathematical formula to find the solution for particular data collections. Next, what is data science? The data science is a manipulate, extract or meaningful information from the knowledge. So the data science, it's related to the database management system. So the data science, it will be do the meaningful information, extract meaningful information from the large amount of data and also the knowledge from the particular data. Next, data science principles apply to all data, big and small. So the big data also evolved by the data science, but the traditional data processing tools were not applied for the big data. But when we are move on to the data science, we can easily handle the big data. Okay. Next, what is data science? The data science is a multidisciplinary used to investigate and analyze the large amount of data. Multidisciplinary means it will include statistical and mathematical and computer science and marketing. So all the fields we can use this data science. Next, computer science. In computer science, pattern recognition, visualization, computing, database, AI. That means pattern recognition, we already see in the healthcare system. Different type of patterns are available. So we can match one pattern to another match. It will be same or different. It will be same means we can take a decision or choose the decision for the patterns. And the mathematical model already I explained. For example, we are collecting some data. That data we have to process it. So for processing, we can apply some statistical problems or mathematical functions for getting the solutions. And statistics also, statistics and stochastic modeling and probability. So finding the probability and mean values. So whenever we collect the data, if you want to find something from this data, we have to apply the statistics techniques to solve the complex problems. The data science multidisciplinary is business strategy, domain knowledge, communication and data analysis, and problem solving and presentation. Those interdisciplinary fields. So we can apply the data science techniques to the all disciplinary to find the complex solutions. And also concentration in database, applied statistic data analytic, solid programming skill like R, Python, like this, data mining, database storage and manipulation, and machine learning. So this type of fields are mostly involved in the data science. So the mathematical and statistical is very important for data science. So whenever we are using data science technology or tools, definitely we can cross the mathematical or statistical technologies. Thank you.